So let us now consider order and degree of a differential equation. The order of a differential equation is the order of the highest differential coefficient contained in the equation. We have an example here. The y over dx is equal to 2x squared plus 3x minus 6 is of order 1. B. The cube y over the x cube plus the square y over the x squared plus y is equal to 2x is of order 3. How do we get an example of A as an order 1? So, according from definition, we all know that in the differential equation, the highest derivative or the highest differential coefficient contained in that equation, given equation, is the order. If you look here now, the derivative of this is y. If we have y, if we differentiate y, we're going to have what? The y over dx. So it means that derivative of a dependent variable is the y over dx. And you can now see that derivative is what? That derivative is what? Is the one in the equation, which is what? What we have is another one. Because the y over dx is only the y over dx that we have here. This one is what? The right hand side here. The right hand side here is independent variable, and we are talking about what? The highest differential coefficient. So the highest differential coefficient in example A is the y over dx, and which is what? Which is another one, because it's a first order. That is, is what? Is a what? First derivative. That is a first derivative and also a first order. So that's why we have order 1. So let us now consider second example. The cube y plus the x cube plus the square y plus the x square plus y is equal to 2x. If you look here, we have a derivative, a differential equation, that is a dependent variable. This is a derivative. This is another differential equation, that is differential coefficient. So if you look here, if you look this b and c, you can see that the cube y all over the x square, it means they differentiate this one 3 times. That is, if you have y, if I have y, if I differentiate y, I'm going to have what? If I have y here, if I differentiate y, I'm going to have the y over dx. If I differentiate this, the y over dx again, I'm going to have what? The square y over what? The x square. If I now differentiate the x square again, I'm going to have the 3y all over what? The x cube. It means here is what? Y prime. That is first derivative. That is, I differentiate this one once. This is what? Y prime prime. That is, I differentiate this one twice. And this is what? Y prime prime prime. I differentiate this one here. So the highest here is what? Is 3. So that is why this is a what? Third derivative. That is, I differentiate this one 3 times. Here it is differentiate twice. And here is what? Is not differentiate. So the highest of that differential coefficient in that equation is the order. So the highest here is what? 3. 3 is the highest. So it's of order 3. If you now consider this, see the y over dx into power of 3 plus the square y over dx square plus y is equal to 0 is of order 2. Why? Yes, it's of order 2. The y over dx is what? How many times with this one is differentiate? It is differentiate once. That is, if you have y, if I differentiate y, I'm going to have the y dx. But here, how many times did they differentiate this? This was differentiated two times. This is a second derivative, and so the highest derivative we are going to take, that is the highest differential coefficient, which is what? 2, because 2 is bigger than what? 2 is more than 1. So the highest here is what? 2. So let us now consider the partial differential equation. The square u over the x dy plus 3 the u over the x is of order 2. Why? Since this the square u over the x dy, it means I'm having u of x comma y. You know that a partial differential equation is a differential equation in which the dependent variable depend on several independent variables. You can say u is a dependent variable depend on what? More than what? One independent, x and y. So if I now have, suppose I have 5x minus 2y here. So I now said u of x, it means I want to differentiate this with respect to x only. It means I'm going to differentiate where I see x here. If I differentiate 5x minus 2y, I'm going to have y 5. So if I now say u of xy, it means I want to differentiate again whenever I see y. So I want to do u of xy, that is uxy. It means I will go to ux. I will not differentiate y. You can see that I don't have y here. I'm going to have 0. If I do it for what? If I do u of y, that is uy, I'm going to differentiate I'm going to differentiate y in this what? In this equation. If I differentiate y with respect to y here, I'm going to have minus 2. If I now say u of yx, it means I want to differentiate y with respect to x. There's no x here, it should be 0. You can see they are the same thing. How many times did I do it? I do it 2 times. So in that case, I can write this as del square u all over del x del y, that is u of x and y. Suppose if it is u of y, suppose if it is u of y and x, it will be del square u all over what? Del y and del x. So it means it is what? How many times did I do I differentiate second derivative? I do it 2 times, I differentiate twice. And this one is what? I differentiate this one once. That is this was differentiate once is a first derivative, and this is what? Second derivative. So which one is the highest? Second derivative is the highest, so it's the order. So the order is what? The order is 2. So that is how to know order of a differential equation. The highest of that differential coefficient in an equation is called an order. So let us now go to degree. Degree of a differential equation is the power to which the highest order differential coefficient is raised. So I will use this as an example. You can see that here the order is what? The order is 1. So the highest of that differential equation, the power of that highest of them is raised, is what? Is called the degree. So since because it's a first derivative is only this that we have in this equation, and the order is what? The order is 1. So the degree will be what? 1. Because if I find the power of this divided by the s, nothing is there, is 1. Because anything raised to power 1 will give us that value. If I now come to b, the cube y over the x square, this is what? Third derivative. This is what? Second derivative. So it means third is what? This order is 3. So the power of this third order, this third derivative is what? 1. Because if I put, there's no power here. If I put it to 1, to the power of 1, I'm going to have this again. If I now check this one, the y over dx is equal to 3 plus the square y over dx. So that highest, you can see because I see 3 here, I cannot say the degree here. The degree is 3. When we are talking about the degree, for us to get the degree, the highest of the differential coefficients will let us know the degree. If you now find the highest of that differential coefficient contained in that equation, the power of that differential highest to that the power to that one, the power to which the highest order differential coefficient is our degree. So you can see that here is of order 2. So what gives us order 2? This is order 2. It means the power of order 2 is what? 1. I cannot say 3. Why? 3 is more than 1. But that highest of this, the highest in this equation is 2. That is a second derivative. This is only first derivative. And I cannot say 4. Suppose if this one is having 5 derivative now, I can say it's 5. So that's why we have it. So it means the degree here is what? 1, and the other here is 2. So order will determine our degree. So order here is what? 2. Since our order here is 2 already, so our degree will be what? Will be 1. So let us now consider this example. Note, for equation which fractional power, the fraction must be removed. So if you have dy all over, if you have a, for us to know our degree, if you have a fraction, it means we have to eliminate the fraction so we can get a value. We cannot get a fraction as a power. So if you have dy over dx into to the power of 2 plus y to the power of 2 is equal to x, is of degree 2. Yes, because if you look here, the highest differential coefficient here is what? Dy over dx. After dy dx, we don't have any differential derivative here. So the power of the highest will give us the degree. So the power to here is what? 2. So that we have the degree is 2. Let us now consider second example. The cube y over the x cube plus 4 dy over dx is equal to 5. You can see that this is what? This is a third derivative. It was differentiated 3 times. And this is what? One derivative. So the highest here, the highest of that derivative will determine our order. The highest here is what? 3. So the power to this highest is what? 1. So that's we have of degree of 1. Some will say 5. It's not 5. We know that the power here is what? 5. The power here is 5. The power here is what? 1. Because I can write like this. 1. But But the highest will determine our what? Our degree. So the highest derivative here is what? The cube y over the x square, which is what? 1. You can see the y over the x is what? The y over the x is just first derivative. Why this one is a what? Third derivative. It was differentiate 3 times. Here it was differentiate only once. So and our derivative, the x derivative will determine our what? Degree. So state the order and degree of the following differential equation. State the order and degree of the following differential equation. So let us consider question 1. The square y all over the x square a square x is equal to 0. So what is the order of this? So the order of this is what? That is the highest derivative here is what? The square y over the x square. How many times? Is 2. So it means it's the second derivative. So the order is what? The order here is what? The order is 2. If the order is 2, so what will now be degree? Degree will not be that the degree will not determine degree will not be the power to the what? To the highest order, which is what? So the power of this is what? 1. So if the order is 2 or the order is 2 or order 2, the order is 2, the order is 2 and degree is what? Degree is 1. So let us now consider this. Y the square y over the x square, y square plus 1. You can see this is the derivative twice. So it means the order here is what? The order here is 2. Order 2. And degree here. What's our degree? Our degree is 1. The power of this is 1. 1. So let us now consider this. The y over ds, this is y. This is not a what? A derivative. Y is just a dependent variable, but it is not differentiate. So this is what is differentiate. The y over ds remains the degree, the order. So you can see that how many when we talk about the order is first order. That is it is differentiate once, and the highest power of that order, the highest is 2. So the degree is 2. So let us now consider the last example. 1 plus the y over ds all into power of 2, 3 all over 2 is equal to the square all over the x square. What is the order? What is the degree? You can say that here, what is the highest differential derivative here is what? This is what the y over ds first order. You can see that our dy over ds is what? First order, order 1. Our dy over ds is what? First order. That is, it is differentiate once. This is differentiate twice. This is differentiate what? 2 times. The square y over the x square, so the highest. So if you consider this one as a what? Highest, so our order will be 2. But it's having a function here, t over 2. It means we have to eliminate it. Note, from equation with fraction power, the function must be removed. How can we remove this one? It means I'm going to multiply this by the power of what? 2. Power of what? Power of 2. So if I multiply this one by the power of 2, I'm going to have this one will be times 2. This is the left hand side. Here also will be what? By the power of 2, so that this 2 will cancel this. So if this one cancel, we're able to have 1 plus the y over the x square to the power of 3, and then what? The square y all over the x square to the power of 2. So it means our order here will not be, so order here that is the highest derivative here is what? 2. Second derivative, second order derivative, and the second derivative is 2, and the what? And the degree is what? And the degree is 2. Suppose we did not eliminate the fraction, we eliminate the fraction. For us to get our answer might not be correct. So whenever we have anything on fraction, we have to eliminate the fraction part so that we can get our degree. So it means our degree here is what? 2. Then our order here is 2. This is how to identify what order and degree is. I hope you find this interesting.